So now, if I want to simplify polynomials that comes with different terms, we are going to manipulate the terms, use the distributive law if you need to, and sometimes you may need to open up the bracket and do other things as well. The idea is to apply that math. So in example 2a, with a bracket minus another bracket, I'm going to distribute the minus in the middle to the bracket next to it. So now all the terms in the second bracket will get a share of the minus. When you group the like terms together, I like to highlight them one at a time. Identify the ones that come with the same degree first. Starting with the highest degree. 3 minus 7 give us -4. And then we have the x. Minus 6x plus 2x give us -4x. And finally, plus 7 minus 9, that give us -2. So this is how we simplify polynomials. Sometimes, besides working with brackets here and there, they may come with a number in front of your bracket. And what you would do is to distribute the number by using a multiplication. So the first group here will give us -16k plus 24. And for the second group, we have 11k minus 22. And now, once I've expanded the constant, once I've expanded the bracket, we see a couple like terms. We can combine the like terms together, and that will give us a binomial at the end. Sometimes your polynomial may give us like terms that are not easily identified because they may switch up the order, or the variables seems to be the same but not quite. What you can do is to rearrange the order within your term. B squared a squared is the same as a squared b squared. Multiplication. The order of your multiplication wouldn't matter in this case. So if I'm to group the like terms together, first of all, open up the bracket. And pay attention to your sign, especially when you see the minus in the middle. And then I have like terms here and there. A squared b squared. Both of them comes with the same variable with the same exponent. This is basically the same as 1 apple minus 3 apples, and you end up getting -2 apples. It doesn't make sense to have -2 apples. But this is the concept. You simply consider the a squared b squared as one single piece. Starting with one of them, minus 3 of them, you end up getting -2 of them. And then minus b squared minus 2a squared. We don't see any like terms for those two, the b squared and the a squared, so we leave them that way. And using the same concept, we can now work with a combination of having brackets, using distributive law, and work with different variables at the same time. So for the next one, the first group gives us these three terms. And the second group, as you can see, I'm trying to color code my steps. Give us the second group give us the last two terms. And as you can see, as I distribute the 2b into the second bracket, I try to rearrange the variable at the same time, and instead of having b times 2b times a squared, I have 2a squared b instead. That makes it easier to simplify your expressions, should it come with any like terms here. But of course, I'm going to start with the one that come with the highest degree, which is a fifth. The benefit of expressing your polynomial starting with the highest degree to the lowest degree is that eventually you will see a pattern for all these terms when it comes to grade 11 and 12, when you get to work with polynomial that has like a third degree polynomial, a fourth degree, a fifth degree. Having your polynomial written from the highest degree to the lowest degree would help you to do a lot of things in calculus, like differentiating your polynomial, graphing it, drawing your polynomial, finding all these properties on your polynomial. Okay?